Since the beginning of civilization, human construction has relied on a single, universal logic. We stack materials on top of each other, fighting the constant downward pull of gravity. To reach the sky, builders spend immense amounts of energy lifting heavy stone, brick, and timber higher and higher. But at the Ellora caves in Maharashtra, India, a group of 8th century architects inverted that logic. Instead of building up into the sky, they carved downward into the earth. This is Cave 16, known as the Kailasa Temple. It is a 3-story sanctuary that descended from the cliff surface down to the valley floor. There are no stacked blocks or assembled walls here. This entire complex was revealed by removing an estimated 400,000 tons of solid mountain. To understand the volume of this project, consider the Parthenon in Athens. The Kailasa Temple dwarfs it. The excavated courtyard measures 82 meters long and 46 meters wide, with the central shrine rising 32 meters high, a scale comparable to a modern 10-story building. Traditional masonry allows builders to replace a cracked block or adjust a wall during construction. Subtractive architecture removes that safety net. Every single strike of the chisel is permanent. Before the first rock was cleared, the architects had to hold the complete 3-dimensional layout of the temple, its halls, pillars, and drainage channels in their minds, trapped inside the solid mountain. A single geometric miscalculation on the roof level would mean the pillars, load-bearing walls, and bridges 50 feet below would fail to align. The builders maintained this spatial coordination over decades, carving the structural blueprint into the bedrock with a degree of foresight that challenges our understanding of ancient engineering. The location chosen for this project added severe physical friction to the timeline. The Charanandri Hills are composed of a volcanic rock layer known as Deccan Trap basalt. Basalt is exceptionally dense, registering a 6 on the Mohs hardness scale. It is used today in road construction because it resists crushing and fracturing. Despite this hardness, quarrymen managed to carve out and manually remove up to 400,000 tons of this rock to free the temple. Historical inscriptions from the period indicate the primary excavation was completed during the reign of King Krishna I, a window of about 18 years. This chart shows the required extraction rate to meet that timeline. Dividing 400,000 tons by 18 years, assuming 12-hour workdays, the volume is staggering. It demands the removal of 5 tons of solid basalt every single hour. This extraction rate pushes the boundaries of human stamina, posing a mechanical paradox that suggests a highly optimized logistical system. The operation began by cutting 3 massive, intersecting trenches straight down into the cliff face, isolating a giant rectangular block of stone in the center. By starting at the summit and working downward, the builders eliminated the need to construct and continuously move heavy timber scaffolding. The unexcavated bedrock immediately beneath their feet served as a natural load-bearing platform. Gravity worked in their favor. Instead of hauling heavy debris upward, workers allowed sheared chunks of basalt to roll away from the working face down the slope of the hill. Carving the intricate roofs and spires first also created a permanent stone canopy. As the workers dug deeper over the years, this completed roof shielded the lower chambers from seasonal monsoon rains. Reversing the direction of construction was a logistical masterstroke that addressed gravity, debris removal, and weather protection simultaneously. This top-down subtractive method led to a direct physical consequence. The complex possessed the structural stability of the hill itself. Because Kailasa is one continuous piece of rock, it lacks the vulnerabilities of traditional buildings. There are no mortar joints to erode and no stacked blocks to slip out of place. The weight of its 3 stories is distributed directly through its solid pillars and into the Earth's planetary bedrock. That stability was put to the test in 1682, when Emperor Aurangzeb deployed his military with strict orders to completely level the temple. A force of 1,000 men attacked the rock-cut sanctuary, striking the pillars and walls with hammers and iron chisels for 3 continuous years. They managed to chip away surface carvings and disfigure several statues, but the load-bearing columns and the main structural bridges held firm. The subtractive engineering of Kailasa immunized it against the vulnerabilities that caused traditional, assembled buildings to collapse. This physical endurance reflects the temple's original conceptual inspiration. It was designed to be an earthly manifestation of Mount Kailash, the eternal and immovable abode of Lord Shiva. The builders realized that to achieve the impossible in engineering, they had to abandon conventional wisdom and reverse their entire approach. Every open corridor and interior hall visible today was once solid earth, manually removed piece by human hands. Replicating this exact feat of top-down precision today, even with modern technology, would remain a logistical nightmare. Throughout history, almost every great human monument was built, but the Kailasa Temple was uncovered.